We're going to focus on simplifying rational expressions and how to solve rational equations. Now, when we touch on this topic, we're going to show you guys how to simplify rational expressions, how to add and subtract rational expressions with the same denominator and different denominators. And then we're also going to talk about how to multiply and divide. And at the end, we're going to then focus on the rational equations. In the first problem, just understand that we're talking about fraction rules, factoring rules, and we're also talking about exponent rules. So if you have a problem like this, always start off with the numbers first, okay? So we could divide top and bottom by 3. So that's going to give us 1 over 5 if we divide by 3. Then from that step, we can now focus on our exponents, right? In the quotient rule, we're going to have to subtract. So, this is x to the 5th. So once we take care of our exponents, right, we don't need this one, that's just a placeholder. We're going to do x to the 5th minus x to the 3rd, which gives us x squared. And then when we have y to the 1st minus y squared, that gives us y to the -1. So when I simplify, what I should have is x squared y to the -1 all over 5. So we understand that we can't have negative exponents. So we're going to take the reciprocal, and our final answer would be x squared all over 5y. Now, problem number 2 is a little bit different because we have to identify this as the difference of squares for us to properly factor. So when we factor this now, it's going to turn into x plus y times x minus y, right? That's why we don't have that middle term. And then on the bottom, what we notice is that we could pull out a greatest common factor of 7. And once we do, we'll have x minus y left over. So now with this step, what we can do is use those fraction properties, and we could cancel out common factors. So x minus y cancels out with x minus y. And what we're left with is x plus y all over 7. All right, I need to use a different blue marker. My bad, family. All right, then we go into our third example, which I would tell students, you're going to see all of these, but this is typically what you'll see, a trinomial. So regular trinomial factoring rules, this is a special case because this is a perfect square trinomial, right? So once we break this down, we're going to have x minus 4 times x minus 4. That is what this perfect square trinomial breaks down to, right? And when we look at it, adds to give us -8, multiplies to give us +16. And then on the bottom, we have the difference of squares. So very similar to the previous problem. So x squared minus 16 turns to x plus 4 times x minus 4. And again, remember, we could now cancel out common factors. So x minus 4 cancels out with x minus 4. And what we're left with is x minus 4 on top over x plus 4. And there's really 2 ways to do this, honestly. The first way, we could multiply straight across, then we could reduce, meaning factor, or we could factor everything and then kind of cancel out like we've done in the previous problems. I'm always going to suggest the second method because multiplying, we're just going to be working with much higher numbers and factoring, and it's going to be a little bit more challenging than it needs to be. So if we're picking the factoring cancel method, let's look at the top. I could take out a GCF of 5, right? So once I divide 5x by 5, we're left with x. And once I divide, when I divide 5x by 5, I'm left with x. And then when I divide 25 by 5, I'm left with 5. Pulled out that GCF. Then in the bottom, right, we're looking for factors that multiply to 6, and it's going to add to 5. And we know it has to be a positive 5, and both our signs have the same sign, right? So we know that it's going to be x plus 2 times x plus 3. Now we factor that out. We go over to the second part of this expression, and we notice that there's nothing for us to factor here. So now this is when we could cancel. And please understand, we could cancel things that are across from each other, so cross canceling, or we could cancel things that are right on top of each other. So I could cancel x plus 3 with this x plus 3, and then I could cancel this x plus 5 with that x plus 5. And as a result, I'm left with 5 all over x plus 2 as a final answer. When we go ahead to factor these two, let's factor these separately. So I'm going to use the slip and slide method, right? So we know we have x squared plus 13x minus 14. Once I simplify this, this is going to turn into x plus 14 times x minus 1. And when we're doing this method, just remember to go back in and divide those two factors by the same number we multiplied. So we're going to divide both of these by 2. My first factor turns into x plus 7. My second factor, because we can't get a whole number when we divide 1 by 2, I'm going to slip it inside in front of that x. So this turns into 2x minus 1. So that is this first denominator. Now let's focus on the second one. So I do the same method, right? X squared plus 7x plus 6. Once I simplify this trinomial, right? Know it got to multiply to give us 6, add to 7. So this is x plus 6 times x plus 1. Don't forget, divide by that same factor, which is 2. So divide by 2, divide by 2. First factor turns into x plus 3. Second factor turns into 2x plus 1. So we took care of the more challenging part. So now let's break down the numerator. So this is the difference of squares, family. So once we break this down, this turns into x plus 3 times x minus 3. And this is all over x plus 7 times 2x minus 1. And then now we go over to our second fraction. So 4x squared minus 1, this is the difference of squares as well, right? I know when you see 1, we don't always think perfect square, but that is a perfect square. And it breaks down to 2x plus 1 multiplied by 2x minus 1 all over. And then here are our last two factors. X plus 3 times 2x plus 1. All right, let's double check the notes. Let's make sure this is correct. Yep, everything looks good. So now at this step, right, we could cross cancel, or we could cancel things that are right on top of each other. So perfect example, let's switch colors, all right? 2x plus 1 cancels out with this 2x plus 1, right? X plus 3 cancels out with this x plus 3. Then we go over 2x minus 1 cancels out with this 2x minus 1. And remember, when we cancel things out, it's just 1 now, right? So this is why you don't see me putting anything there. It's just 1. So all that we have left is x minus 3 on top. Everything canceled out to 1. So we have x minus 3 on top, all over, and the only thing that I have on the bottom is now going to be x plus 7. And this will be our final answer. Yep, double check the notes so we're correct. When we are doing these type of problems, the first thing I'm going to tell you is to go in there and turn it into the multiplication problem, because this is still a fraction. Meaning what? This stays the same. So we have 2x squared plus 4x minus 6 all over 4x plus 12. Change this to a multiplication sign, and now we take the reciprocal. That's why I said those fraction rules still apply. And this is the same exact thing as multiplying rational expressions. Apart from that, we have to go in there, change the division to multiplication, and take the reciprocal of the second fraction. So now we have x to the third minus 6x squared minus 7x on top, all over 3x to the third minus 3x. Now that we have that, we can now break this down in factor, and I'm going to switch over to black. So the first thing I want to do here is pull out a greatest common factor of 2. Okay, so when I pull this 2 out, what I'm left with is x squared plus 2x minus 3 all over, and I'm going to do the same thing here. I'm going to pull a GCF of 4. So if I divide this by 4, all we're left with is x, right, plus 3. Then I'll go on to the other side. We're going to do the same exact thing. So what I want to do is let's just pull out an x. Change this into a regular trinomial, which is x squared minus 6x minus 7. All over, and then on the bottom, we're going to pull out a GCF of 3x, okay? So when I pull that GCF out, I'm left with x squared minus 1. Now, when I go ahead now up to this top portion, we're going to break this down a little bit further. So at this step, I'm looking for the factors, right? Multiply to 3, add to 2. So when I rewrite this, we're going to have 2 times, let's write these out. Oof, I don't have that much space, family. Hold on. All right, let's erase right here. All right, so let's just bring this up here now. So if you're following with me, we're right here. We're trying to factor these down now. So we're going to have 2 times, and let's write these out. So it's going to multiply to give us 3. Let's see. So this should be x plus 3 times x minus 1. All over. We already factored that as 4. Pulled out that 4. Stays the same. So now once we factor this trinomial on the other side, right, x squared minus 6x minus 7, what we should have is x minus 7 times x plus 1, right? That's absolutely correct. All over 3x. And then we're going to focus on this difference of squares, right? This is what we need to break down. And it's going to break down as x plus 1 times x minus 1. And let's just double check to make sure we're on the right page. Yep, we look good. All right. So now at this step, family, we have factored everything. Now we're able to cancel things out. So when I look here, x plus 1 cancels out with this x plus 1. I have x minus 1 with this x minus 1. And then, like I said, not only could we cross cancel, but if things are on top of each other, we could cancel those as well. So now what I'm left with, and please mind you, right, let's just look at it. This is what we're left with on this side. 2 over 4. We're left with x over 3x, and we have x minus 7. So what I would do right here, and let's just switch colors so this sticks out. Divide this by 2. That's 1. Divide this by 2. That's 2. Let's cancel out these x's. And now what we have left over, there's nothing on top except for 1 times x minus 7. So we have x minus 7 on top, right? Everything else canceled out. And on the bottom, we have 2 times 3, which would give us 6. And I believe this is the final answer. I don't think there's anything else. Yep. So our final answer should be x minus 7 all over 6. When we get over to the unlike bases, right, we're going to start there first. I think this is the more important one. Please remember, the first thing we want to do is to factor everything. If there's anything for us to factor it out, and then identify the LCD, the lowest common denominator. So when I look at this right here, right, LCD is probably going to be 20x, right? That's the lowest common denominator between these two. So if I want to get to that lowest common denominator, what would I need to multiply both of these fractions by? So this first one, 9 over 4x, I could multiply top and bottom by 5. So this gives me 45 over 20x. And in my second fraction, if I want to get it to a denominator of 20x, I'm going to multiply bottom and top by 4. So this is minus 28 all over 20x. Now, don't forget this. This used to happen to me in middle school, high school. Denominator stays the same. We're just combining the numerators. So once I subtract, I did look at my notes. 45 minus 28 is going to give us 17. And this is all over 20x. Anytime you get a final answer, just check to see if you can simplify. This right here, we can't simplify 17 and 20. There's no number that we could divide both of those by. Now, second one, right? When we're dealing with those bases that are not the same, factor, because we won't understand what this denominator is. So first one stays the same, right? 7 over x plus 4 plus 3x plus 68. However, this is the difference of squares. So now this breaks down to x plus 4 times x minus 4. So for us to combine these, this denominator is only missing what? X minus 4. So now I'm going to come over here. Let's fill it in the bottom. And just like here, what we do to the bottom, we do to the top. X minus 4. So when I distribute 7 to this, we're now going to have 7 times x, which gives me 7x. 7 times negative 4, negative 28. And I'm going to rewrite the rest of the numerator. So plus 3x plus 68. And I'm going to put this all over the common denominator, which is what? X plus 4, x minus 4. So real quick, I was not going to touch on this, but when you're doing these rational expressions, we have to identify those, what the denominator can't be. So when we look at our denominator, let's say in this first problem, right? We know that x cannot be equal to 0, because if x is equal to 0, this would be undefined. Now, when we apply that same rule to here, to the second problem, what we're seeing is that x cannot be equal to 4 or negative 4. Because if we get those in the denominator, right? Negative 4 plus 4, that's 0. And once we multiply that by the second binomial, we're going to have 0 in the denominator. We cannot have that, all right? All right, so now we're just combining numerator. So this turns into 10x, right? Negative 28 plus 68 is going to give us positive 40. And that's all over x plus 4 times x minus 4. Now, if you stop right here, this problem is wrong. Why? We could factor this numerator, and you always have to double check, please. So what I'm going to do is pull a GCF of 10, all right? And let's just go back to black so this sticks out. So right here, we pull out that GCF of 10. We're left with x plus 4 all over x plus 4 times x minus 4. Nothing happens to the denominators, they stay the same. So now I cancel out, right? X plus 4 with its common factor, x plus 4. And I'm now left with the final answer, 10 over x minus 4. All right, so please remember, when we're adding and subtracting with unlike or, different bases, different denominators, please remember that we're dealing with fraction rules. And if you need to add something into the denominator, right, meaning x minus 4, just make sure you multiply the bottom and the top by that common binomial or denominator, I should say. So when we have the same denominator, just combine this. So what they're saying is this is x squared plus 3 minus 4 all over x plus 1. We just combine both those fractions into 1 since they have the same denominator. And now we just focus right here, right, on the like terms. So the top turns into x squared minus 1 all over x plus 1. Now remember, we always have to double check when we think we have our final answer. Difference of squares. So this turns into x plus 1 times x minus 1 all over x plus 1. So at this step, we are done factoring. We can't factor anything more. However, we notice that we have common factors. So I cancel x plus 1 with x plus 1, and my final answer is just x minus 1. We don't have to put it over 1 because this is the same exact thing. Now let's go over to the second one. And the reason I want to touch on this second one is because please make sure you apply this negative to each term, okay? It's like distributing, all right? Sometimes students will only apply this negative to the first number, and if you do that, you will get this wrong because 5 is going to have the wrong sign. So let's just put this all over 1, right? So 5x plus 2 minus 4x minus 5. Once we distribute that negative, this is what we're going to have. Let's just double check. Yeah, I know I'm right. All right. Then on the bottom, let's factor everything. So we factor this as x plus 3 times x minus 3, difference of squares. And now we could simplify. So 5x minus 4x gives me x. 2 minus 5 gives me negative 3. And this is all over our same denominator, x plus 3 times x minus 3, right? You guys with me? All right, perfect. I know y'all with me. Now the same thing applies. Can we cancel out common factors? And yes, we can. X minus 3 cancels out with x minus 3. Now, just remember, this is a lot different from this because x plus 3 is in the bottom. So if we cancel out and this is 1, just please remember that this 1 is still a placeholder. So our final answer would be 1 over x plus 3. Don't make that mistake and think that it's a whole number or it's over 1 like in this example, okay? If this was like a test, we'd have to go ahead and say that, hey, x cannot be equal to negative 3 because that'll be undefined. You always have to identify those extraneous solutions or what x cannot be, okay? So the first method is always to cross multiply. And I'm telling you, if you have a simple rational equation like this, always follow this method, okay? So once we multiply x minus 3 times x plus 3, we're going to get x squared minus 9. And that is equal to 2 times 3x minus 7. So we're going to focus on this side and distribute. So this turns into 6x minus 14. And this side stays the same. Now, before I continue to go on, just remember that in 9 times out of 10, when we have a rational equation and we cross multiply, we're either going to get a linear equation, which is just an exponent of 1, something like this, or we're going to get a quadratic equation where we have an exponent of 2 and we have to factor to solve. So please remember those two instances, okay? So what I'm going to do is I'm going to bring 6x over by subtracting, right? Bring 6x over. And I'm going to keep it in standard form. So we have x squared minus 6x minus 9 is equal to negative 14. Now, remember, we're creating that trinomial. So now we're going to add 14 on both sides. So now I have x squared minus 6x, I want to say plus 5, yes, plus 5 is equal to 0. And now this is when I'm basically done with this problem because now I can solve. All right, beautiful. And what we're going to get, y'all should be able to see this, right? Is we're going to have x minus 5 times x minus 1. And this is equal to 0, right? So we know once we multiply, positive 5, once we add negative 6. Now, students get this wrong because they stop right here. Please set your factors equal to 0. So x minus 5 is equal to 0. That means x is equal to positive 5. And then when we go to our second factor, x minus 1 is equal to 0. So we know x is equal to positive 1. You may also see it expressed as a solution set, meaning x is equal to, and then we have in braces both our answer. So 5, 1, and then we close those braces. All right, so when we're doing the lowest common denominator, right, when we're trying to get rid of it, I like to use a box and identify what is the denominator. It would be 2 times x plus 3. And I write it on both sides. And I'm going to show you guys why. So on this right-hand side, this equation, x plus 3 cancels out with x plus 3. So now I focus on 2 and I distribute it to 3x minus 7, meaning what? I'm going to get 2 times 3, which gives me 6x, 2 times negative 7, which gives me negative 14. Go on the other side, we're going to do the same thing. 2's cancel out. I distribute x plus 3 to x minus 3, which is going to give me x squared minus 9. So I'm right back at the last equation that we just did. And it wasn't too much work, right? It wasn't too much work. Now we do the same thing. I subtract 6x. So we have x squared minus 6x minus 9 is equal to negative 14. Then I do the same thing again. We're trying to solve this quadratic equation. So after I add 14, we're going to have x squared minus 6x plus 5 is equal to 0. And then we just go right through factoring, setting those factors equal to 0. All right. I am going to do the cross multiplying method. So for some reason, when students have more than just two fractions, right? So let's say we just had these two, it all of a sudden becomes more complicated, but family is the same thing. So this is one method you could do. We could combine these two sides, meaning if I multiply this by 2, this will give me 2x plus 6. So let's multiply this by 2, multiply that by 2. So my first fraction stays the same. 5 over 2x plus 6 minus 4 over what? 2x plus 6, and this is equal to x over 8. So now at this step, remember, this is the same denominator, so we could just combine. 5 minus 4 gives me 1. That's all over 2x plus 6, and this is equal to x over 8. And then now we go into the cross multiplying. 8 times 1 gives me 8, and this is equal to x times 2x plus 6. So we should know that this is going to give us a quadratic equation, meaning what? 8 is equal to 2x squared plus 6x. I'm going to subtract 8 from both sides to create that quadratic equation. Now we have 0 is equal to 2x squared plus 6x minus 8. So now I'm going into factoring. So when I take this problem up here now, and let's just switch back into blue so it pops out, we have 0 is equal to, and did you guys also notice that we could pull a greatest common factor out? Yeah, we can. So when I pull that 2 out, we're left with x squared plus 3x minus 4. And now I'm focusing on what's inside the parentheses for me to factor. So 0 is equal to 2. And let's see, what factors are we going to get? Multiplies to give us negative 4. Adds to give us positive 3. So what I'm thinking is x plus 4, right? Larger number has to take the sign of the middle number. And if we want a negative, when we multiply, this has to be negative. Let's just double check the notes. Yep, x plus 4, x minus 1. Now we set all our factors equal to 0, including this outside number. So 2 is equal to 0. That's not true. Toss it out. X plus 4 is equal to 0. Okay. X is equal to negative 4. There goes our first x. Second x. X minus 1 is equal to 0. When we simplify that and add 1 on both sides, we know x is equal to positive 1. So if you were doing it the other way, this is what I would have told you guys to do. I would have simplified these two, right? And I would have got to this step. Then after here, we could have just combined and had 1 over 2x plus 6 is equal to x over 8. Then I could have said, okay, what's the common denominator? And the common denominator would have been 8 times 2x plus 6. Let's write it on the other side. And you don't have to write it on both sides, but I always found this helpful. So on this side, the 8's cancel out, right? We're left with 2x plus 6 times x. So x times 2x gives me 2x squared. X times 6 gives me 6x. Now on the other side, right? Guess what? 2x plus 6 cancels out with 2x plus 6. We take what's left over, 8, and multiply it by the numerator. 8 times 1 gives me 8. Right back at the same step. So after I subtract 8, 0 is equal to 2x squared plus 6x minus 8. Now we're back at the same trinomial that we just solved, math family. So this is another method that we could have used where we cleared the denominator altogether. Really hope that this review was helpful for you, math.